Hi everyone, here is our math problem for today. We are given here this yellow circle with a radius of 4 units, and another blue circle with a radius of 2 units, and a third circle, this red circle, with a radius of r units. These three circles are tangent to each other, and all of them are also tangent to this external white line. We want to find what is the radius of this red circle. You can pause the video and see if you can solve this math problem. If you already have an answer to this problem, please write them in our comment section. Now let's solve this problem together. Let's begin by constructing a radius from the center of this yellow circle perpendicular to the white line. And let's also drop the radius of this red circle. Then from the center of the red circle, let's construct a line perpendicular to the radius of the yellow circle that we just constructed. And from the center also of this red circle, let's connect this to the center of this yellow circle. The angle here is 90 degrees, and the angle here is also 90 degrees. And let's label the parts. Now let's focus ourselves on this right triangle ABC. The length of leg AC is the radius of the yellow circle minus this radius of the red circle. And so we have here the expression 4 minus r. That is because this line BC is parallel to the white line, forming this rectangle here. And so opposite sides are equal. Then the length of side AB is the sum of the radius of the yellow circle plus the radius of the red circle. So we have 4 plus r. 4 is the radius of the yellow circle. R is the radius of our red circle. When two sides are known of a right triangle, we can easily compute for the length of the third side using the Pythagorean formula. So let's compute. So the side BC is equal to the square root of the difference between the squares of the hypotenuse and one of the legs. So this is the measure of the hypotenuse, this is the measure of the leg, and we get the difference. Simplifying, we can expand this binomial this way, and we can expand the other binomial this way. Then we can remove this grouping symbol to arrive at this next line. And from here, 16 minus 16 is 0. R squared minus R squared equals 0. And so what's left is the length of segment BC is equal to the square root of 8r plus 8r, or the square root of 16r, simplified to BC equals 4 square root of r. Let's remember that value here. Next, let's consider this blue circle and this red circle performing the same process as we did with the yellow and the red circle. So again, let's drop this perpendicular segment, which is the radius of the blue circle. So the angle here is a right angle. And let's do the same with the red circle. Then from the center of the red circle, let's draw a line segment perpendicular to this radius of the blue circle that we just constructed. The angle here is a right angle, and so we also have here a rectangle. Then let's connect the centers of the blue and the red circles, and let's label the points. Then let's consider this right triangle DEB. The length of side ED is the radius of the blue circle minus the radius of the red circle, so 2 minus r. The hypotenuse EB is equal to the radius of the blue circle plus the radius of the red circle, so we have 2 plus r. From here, we can compute the length of side DB. So BD is equal to the square root of the difference of the squares of the hypotenuse and that of one of the legs. So the hypotenuse is 2 plus r, the length of one of the legs is 2 minus r, and we get the difference of their squares. Then expanding the corresponding squares of binomials, we arrive at this, and removing the grouping symbol, we arrive at this, and combining like terms, we have the square root of 8r for the length of BD, which is simplified as 2 square root of 2r, or we can further rewrite it as 2 square root of 2 as the coefficient, and the variable is square root of r. We want this last form because this is easier to compute in our next computation. Let's remember this value of BD. Then we know the length of BD or DB, And we know the length of BC. Since it's right angle here, and right angle here, the points D, B, and C are collinear. And so we can now find the length of DC by just adding BC plus BD, and that gives us this expression. Since these are like terms, we just have to add their coefficients 4 plus 2 squared of 2 and copy the common literal coefficient. Then let's proceed to our final step. Let's connect now this center of the blue circle to the center of the yellow circle. What is the measure of segment EA? That is the sum of the radius of the blue circle and the yellow circle. So we have 2 plus 4 or 6 to be the length of segment EA. That is because when two circles are tangent, the center, the point of tangency, and the other center of the other circle are all collinear. Then let's connect this center to this point, making a line segment parallel to this side DC, and let's construct this right triangle. Since the radius of the yellow circle is 4 units and the diameter of the blue circle is also 4 units, we know that we can form here a rectangle. And therefore, the angle here must be right angle, and we have a right triangle. From this right triangle FEA, we know the length of the hypotenuse to be 6. We know the radius here, which is also the side of the right triangle, to be 2 units. Then we can easily compute for FA. But FA is already known to be equal to DC because we have a rectangle. And so knowing these 3 values, we can now compute for the value of R. So we form this equation using Pythagorean formula. The square of the hypotenuse is 6 squared. The square of this leg is 2 squared. And the square of side FA is equal to the square of the length of side DC. And this is our previous result. I just use a different color here to emphasize that this value here is just a numerical coefficient of this literal coefficient. And the operation here is multiplication. Now simplifying, square of 6 is 36, square of 2 is 4. The square of this is this expression raised to the second, and the square of the square root of R is simply R. Then 36 minus 4 is 32. We are going to square this part, so 4 squared is 16, plus twice the product of 4 and 2 square root of 2 to get 16 square root of 2, plus the square of the second term, which is 8, and we copy R. And 16 plus 8 is 24, so we can further simplify it this way. And solving now for R is 32 divided by the quantity 24 plus 16 square root of 2. And simplifying this result and rationalizing the denominator, we arrive at R equals 12 minus 8 square root of 2. And this expression is approximately equal to R equals 0.6863. And this is now the radius of this red circle. And this is now our final answer. So thank you very much, and we hope to see you again in our next video. Bye for now.